Hello, my name is Claire Higginson, and this is the second paper reading assignment. The paper I read was Minimizing Cyber Sickness in Head Display Systems, Design Guidelines and Applications. Head-mounted displays, or HDMs, are becoming more and more popular in the current gaming industry. With its use on the rise, other industries are looking into using virtual reality for other, more serious applications, such as healthcare. However, these headsets are still very much in development and have one major flaw: they cause many users discomfort or sickness for a variety of reasons. This poses a problem not only for the gaming world, as users won't want to play games that make them sick, but also in more serious applications such as healthcare. Therefore, this paper researched and designed an experiment that attempts to mitigate one major cause of sickness in HDMs: focus. However, the issue with focus in virtual reality is not the only factor that can lead to discomfort or sickness from HDMs. Sudden acceleration changes can contribute to uneasy feelings due to the duration of the acceleration change. If the change is instant, users won't feel discomfort. However, these problems arise when the screen speeds up and slows down. The degree of control over the camera movements can lead to discomfort if movements are not initiated by the user, yet the camera still moves. This ties in with unrealistic body movements, latency, and field of view. When the in-game avatar performs movements that are unrealistic, or movements that the user is not physically doing, the disparity in vision can lead to sickness as well. A disparity also arises when latency occurs in-game, as frame rate drops can cause unexpected and sudden movements that the user is not performing themselves. Manipulating the camera field of view also causes unnatural movement, leading yet again to discomfort and sickness. Users can also feel discomfort if they use the system for too long. However, these are all problems that can be fixed with some software design and development. For example, acceleration can be fixed by producing close to instant accelerations, and users could have a greater degree of control over understanding where their avatar will be moving by implementing visual foreshadowing in-game that shows camera movements before they happen. Unrealistic body movements and field of view could be fixed with a similar solution, and latency can be fixed by improving software and code. Users could even be notified to take a break periodically to reduce duration of use and therefore sickness. However, a larger discomfort issue arises with the type of focus in the headset. Computer-generated graphics are generally in infinity focus, or rather, all the objects are in the focus regardless of their distance away from the user. This is not representative of real-life vision and therefore can be uncomfortable for users. Implementing some sort of eye tracking system to determine when users want what objects to be in focus is a common but challenging solution to this problem. However, the study designed guidelines for how to reduce focus discomfort without using eye tracking. First, the guidelines for the system were designed to be as follows. The blur level of the system must be subtle enough to match the depth effect that occurs in real life, and users need to be able to alternate between focusing on near or far objects to also account for blur and depth. It also takes a little bit of time for our natural eyes to adjust to new objects in and out of focus, therefore there needs to be at least 500 milliseconds delay between refocusing. Finally, focused objects can't necessarily be only in the center of the screen, even though that would be the simplest to implement. Human gaze focuses on different objects due to point of interest, not where they are on the screen. The solution this paper came to for this problem was creating a heuristic model to represent the guidelines previously mentioned. It can evaluate the number of metric rays hitting a scene object, which are weighted depending on how close each layer is to the center of a cone, much like the shape of the inside of your eye. Using this model, a virtual space shooter game was created using the Oculus Rift HMD. It implemented this dynamic focusing using the heuristic rather than eye tracking. The picture shows the game demo in infinity focus on the left and in the created dynamic focus on the right. Finally, test protocol was created so that readers would have the ability to reproduce the tests if they so choose. It was suggested to use a simulator sickness questionnaire shown in the table, as well as a profile questionnaire asking basic traits such as age and gender. The table can be used to evaluate the answers to the simulator sickness questionnaire, which uses a 4-point scale from 0 to 3.